So shall we begin, sir?
Yeah, no problem. Yeah. So,
Let me introduce you, sir. Hello.
thank you. Yeah.
Yes, sir. A warm welcome to Dr. P. Eshwaraiah, sir, from GITAM University. And sir is also from GITAM Hyderabad campus. And a warm welcome to all the participants. Presently, Dr. Eshwaraiah P. is working as a professor and HOD Mechanical Engineering in GITAM Hyderabad campus. Today, sir is going to present a topic titled Sustainability with Additive Manufacturing, which is shortly called as 3D printing. It's my privilege to introduce Dr. P. Eshwaraiah, sir, on this occasion of 4th day of Atal FTP session. Sir has obtained his PhD from IIT Delhi in 1997 and Masters in College of Engineering, Andhra University, Visakhapatnam. And Sir has obtained his BTech in 1991 in G. Pullareddy College of Engineering. And Sir has total of 22 years of experience, and his research domains are computer-aided design and computer-aided manufacturing, computer-aided process planning, additive manufacturing, advanced manufacturing system, and advanced materials and engineering. Sir has many research publications in national and international journals, and he has guided many PhD scholars and 13 active scholars right now under him. And he also guided many PG students and UG students. And he also attended various conferences, workshops, and FTPs. And he also conducted many FTPs also. So a warm welcome you, sir, once again. It's a privilege to have you here. You can start the session now, sir. Thank you, sir. Thank you very much.
Thank you, Raghu.
Thank you, sir.
Thank you for introduction. So is my voice audible?
Yes, sir. It is audible to all of us, sir.
Okay. So first of all, I would like to say good afternoon to everyone, all of my participants. So let me understand my audience. Is everybody is faculty in various colleges or student community also there?
So only faculty members, sir.
Okay, faculty. Okay, good.
Yes, sir.
So yeah. So today I am planning to give some kind of highlights on sustainability with additive manufacturing, 3D printing. So it is my plan of presentation, how to control it. Yeah. So this is my plan of presentation. I'll be highlighting differences between subtractive and additive manufacturing. And what is additive manufacturing? I'll be touch upon. And I'll discuss a little bit about tools and technologies or processes or methods used in additive manufacturing, materials used in additive manufacturing, applications of additive manufacturing, 3D printing facts and forecasts, and not last but not the least, I'm going to touch upon what do you mean by sustainability with additive manufacturing. So before going full-fledged, what is subtractive manufacturing with the audience? So whatever the conventional manufacturing we do in our conventional machine shops or factories, where a block of material will be removing the material, right? So for example, you want to manufacture a sphere. How do you manufacture a sphere? So you will take a block of raw material and start removing the material in a curved fashion until you get a sphere shape, right? Whereas that is really an old method of doing. But at the recent times or last 4 decades, the method of doing is not exactly 4 decades, it's exactly 2 decades. Generating a 3D model of the sphere and then generating a CNC code, computer numerical control code, and then machine away unwanted material. If possible, you will recycle the waste. So that is the way we are currently doing as a subtractive manufacturing, creating a component. Maybe as of now, it may be a sphere which we are talking, but any kind of feature to manufacture. Essentially, what we are doing is taking a raw material block and removing the material. So that's why the word called subtractive. Okay. Now I am going to take you what is additive manufacturing. In contrast to that, the additive manufacturing is the process of joining materials to make objects of 3D data, 3D model data, usually layer upon layer, as opposite to subtractive manufacturing method. So, in a subtractive manufacturing method, we are removing the material from the initial block. Whereas in additive manufacturing, as the term indicates, we are go on adding the material layer by layer upon layer or layer by layer. So that is the difference. If you look at a closer way, so what is happening here in the abstract additive manufacturing? The creation of solid models usually happens with CAD models, CAD tools or CAD softwares. And then that software, once you have a CAD model, then you have another software called softwares available for slicing. We call it as slicing softwares. There, this 3D model will be sliced into a small thin slices. And then we will give that slice data, we will input as to the 3D printer, and that builds the layer by layer as it is shown in the picture. So the each layer gets built up, then you will get a component. So many of you may be aware of this technology very well, but here I would just like to touch upon some differences between subtractive and additive manufacturing. So this picture indicates essentially in a subtractive manufacturing, in the first line, raw material block will be taken into machine, and then you will cut the material. So in the process, what you will get a 3D object, physical component, plus some wastage of material. Whatever you cut, whatever you subtract, that material is a wastage. Sometimes you will reuse that, but you have to, in order to reuse, you have to process it again. Whereas in additive manufacturing, we will have directly the material in the form of powder or in the form of a wire or in the form of a fine particles or granules, and that will be poured onto using a slicing software and a 3D printer. That will be build, the object will be built layer upon layer, then you will get a 3D object. So here sometimes you might need to do a minor post-processing activity to make it a final finish. There you will get some amount of waste, but that is very minimal waste. So essentially in this process, in the subtractive method, the wastage of material is more, and in the additive manufacturing, the wastage of material is very less. If the raw material cost is very less, that doesn't matter much. But when you are producing a components, the initial raw material cost itself very huge. There it matters a lot. Even if it is 30 to 40% wastage is a huge amount in terms of production cost or in terms of raw material cost. That here in the additive manufacturing directly saving. And another important thing here in the additive manufacturing, we are not using any tools to cut. Whereas in the subtractive manufacturing, we are using multiple tools to achieve the features. Okay, so that we need to understand it. So I got some interesting video I would like to play. Are you able to hear the video?
Hello, sir. There is no audio in this video, sir. Only
There is
video.
no audio in this video, is it?
Yes, sir.
Okay, that's why I got doubt. So, is there any way can I add an audio?
Yes, sir. It is possible. When you're sharing the screen, there is an option at the bottom, sir, like share with computer audio.
While sharing the screen, you have to say share with the computer audio, right?
Yeah, yes, sir. There will be an option at the bottom left side, sir. If you opt it, the voice will come. Yeah.
1 minute. 1 minute.
Sir, it will be in the share screen option.
In the share screen, 1 minute. I am just
Yes,
going there.
Okay, sir.
Where is this? Okay, sorry for that. I don't know why my screen is not coming. Okay, I had to say stop sharing. Sorry.
Yes,
yeah.
sir.
So in the sharing options,
Yes,
you are
sir.
telling
There will be computer audio. There will be one computer audio at the bottom, sir.
Share with computer sound.
Yes, sir. Sound.
I had to click that. Okay.
Yes, sir. That you have to opt, and the one which you are playing now. If it is PPT, then it will come through PPT only, sir.
Okay. So optimize screen sharing for video clip. Not required.
Not required. Not required. Not required.
Okay. Now, now. Okay. Thank you.
Thanks.
Thank you for that. Now
Yes.
I will share the screen. Is it?
Yes, sir. Now it is there. Now it is audible.
Good. Yeah. Thank you.
Thank you, sir.
Thanks for that. So,
what is additive manufacturing? Additive manufacturing, also known as 3D printing, is a process that creates a physical object from a digital design. An engineer designs the object using computer-aided design, or CAD software. The 3D design file is then sliced into thin layers and uploaded to an additive manufacturing machine. The manufacturing process begins once an extremely thin layer of metal powder is spread across the platform. A heat source, such as laser or electron beam, then melts the first layer of the 3D design. The platform is lowered, and another layer of metal powder is spread across the platform. The layering and melting process is then repeated until the part is complete. The metallic powder is removed, and a physical object is revealed. Additive manufacturing allows you to produce parts that are lighter, stronger, and more durable than traditionally made parts. Build times are faster. Engineers can add precise features and complex geometries without increasing cost. In fact, additive manufacturing is revolutionizing the way we work.
Okay, so that's about the introduction of additive manufacturing. But in general, there is a confusion between what is 3D printing and additive manufacturing. Actually, 3D printing is a additive manufacturing. So, in one more video, I just would like to show you.
3D printing technology is already changing the way we produce objects, from tools and toys to clothing and even body parts. 3D printing is part of a process known as additive manufacturing, where an object is created by adding material layer by layer. Additive manufacturing allows designers to create complex parts for machines, airplanes, and cars at a fraction of the cost and time of standard means like forging, molding, and sculpting. Now, smaller, consumer-friendly 3D printers are bringing additive manufacturing to homes and businesses. The first step in 3D printing is to create a blueprint of the object you want to print. You can use modeling software like Blender to create your own designs, or you can visit websites like Thingiverse or Shapeways to find objects other users have 3D modeled. Once you have a finished design, it's time to send it to the printer. Some printers, like the MakerBot Replicator 2, have renewable bioplastic spooled in the back of the device, almost like a string. When the printer receives the data, it pulls the material through a tube, melts it, and deposits it to the plate where it instantly cools. As you can see, the 3D object is created through layering, where the printer will add one layer of the object at a time until you have a fully formed structure. The most common material used in 3D printing is plastic, but the use of some other materials allow for the creation of some pretty amazing products beyond simple tools and toys. 3D printing food is becoming very popular, and additive manufacturing has allowed for the creation of some pretty intricate treats. In the medical world, doctors are testing biomaterials for regenerative medicine. By using a patient's cells, doctors could 3D print small body parts like ears and noses. Some surgeons have even tested 3D printed organs for transplants. Recently, giant 3D printers in China printed 10 houses in just one day and at a cost of less than $5,000 per house, proving just how cost and time-efficient 3D printing can be. For more on 3D printing, check out Mashable's latest coverage. And don't forget to watch the 3D printing tech.
Okay, so through these two videos, I would just like to introduce what is additive manufacturing and 3D printing. So essentially, both are same. So the key thing here is to design your component. So that is up to your imagination. So as a faculty, what we need to understand here is, in order to effectively use this technology, we need to encourage our students to do a better modeling. As of now, what is happening in our institutes, majority of times, according to the syllabus, some portion of engineering graphics we are teaching for mechanical students, the manual drawing, some basic elements, entities like line, curve, etc., planes, etc. And later we are taking them to AutoCAD, how to create these basic entities. In the subsequent years, in the second and third years, we are introducing some kind of modeling of the components, and subsequently some mission design. And then we are asking them to do some kind of projects using these components. So that much only we are able to give. But in order to effectively use this technology, the simple entities of line, draw, curve, and planes are not sufficient. So in order to build a complex model, there is a concept called curves, curve generation, surface creations. Majority of industries like automotive, aerospace industry extensively uses a surface modeling, and automobile industry uses solid modeling as well as surface modeling. So The advanced modeling concepts like creation of curves, complex curves like splines, Bezier curves, B-spline curves, giving the knowledge of these curves and the operations involved in generation of surfaces, then only the students can able to understand the intricacies of the designs and then able to model. Once they are able to model, so rest of the thing like generation of slicing through using slicing software and importing that information to 3D printer and printing, that is not a very big challenging task. But the creation of a effective designs and setting the parameters while using the 3D printer, because sometimes some profiles requires some supporting material. Otherwise, when you are pouring the material before solidification, that might drop on the bed. So if in such cases, if you don't provide a sufficient supporting materials, you cannot get a accurate component printed. So those are the challenges involved in this technology. So let's look at what are the methods and technologies involved in this 3D printing or additive manufacturing, and what kind of materials it can print. Okay, so the three major processes are molten polymer deposition, or we call it as fusion deposition modeling, where the material is in terms of kind of wire that will be melted, and based on the slicing profile, the material will be poured onto the bed, and after completion of one layer of thing, and the bed will go down the equivalent to one layer thickness, and then next layer will be formed, poured, and then subsequently layer by layer the component will be built. Whereas the second methodology is SLS, selective laser sintering, where granules of material will be poured, and using laser, that heat will be supplied, and based on the layer profile, that the powder which is applied, the heat applied onto the powder, that will become it solidifies and forms a shape. And photopolymerization is another method, SLA, stereolithography. So here the light source will be applied onto the material and to form the shape. So let's look at these three technologies. And apart from this, some more methods are there we will be looking at. So in one of the video, they are explained very well what these three technologies. Let's look at it.
Additive manufacturing, otherwise known as 3D printing, could one day be responsible for the second industrial revolution of sorts. The hype of 3D printing started small, but has continued to transform for the last 25 years and has began rapidly advancing.
Just to be clear, additive manufacturing is the manufacturing of tangible 3D items with the use of a printer. This is made possible through the use of computer software and a printer head or a laser to assemble objects from the bottom up in fine layers.
Although the technology has been in the works for 25 years, it has been a slow process of development. However, there are now a few 3D printers available on the market at a very reasonable price. There are three types of additive manufacturing methods, which include selective laser sintering, fused deposition modeling, and stereolithography.
Created at the University of Texas, selective laser sintering is a process using white nylon powder called polymer to create 3D objects. The polymer is laid on a 3D machine and then rolled down to create a fine layer. The engineer then uses CAD to create an object which only is limited to the imagination and then processes this through the machine. The SLS method uses a laser to scan the surface of the powder. It fuses the polymer together to create a 407-inch layer. This process is repeated over 1,000 times to create an object. Once this is complete, the machine ejects the object for the engineer to brush off the excess powder using cleaning tools similar to those used in dentistry for the final process.
Deposition modeling is the process of additive manufacturing where the 3D printer sprays a thin layer at a time over and over to eventually create an item. The process requires little human involvement. The engineer uses patented software called Stratasys fused deposition modeling technology to design the object and then either ABS, polycarbonate, or polyphenol sulfone to create the strong, durable parts. Once the engineer has made the model on the software, the machine takes over and sprays the design. Once the process is complete, the part is then submerged into a water-based solution where any supporting structures are dissolved. The final product then has a smooth finish with fine details.
Stereolithography is the combination of photochemistry, laser, and software technology used together to create an object from a gel. The CAD data is designed and then sliced into very thin cross-sections. A beam of ultraviolet light is focused on the surface of a liquid photopolymer tracing the design. The product turns the liquid layer into a solid plastic. Once a single layer is completed, it then lowers the SLA machine slowly until the object is complete. This continues until the product is completed, where it goes into an ultraviolet oven to cure the part. This requires little supervision while working around the clock.
Additive manufacturing has cast a new light on the way items are made in today's world. With our technology, there is no limit to what we can create with the use of computer-aided designs and 3D printers.
It is inevitable for everyone to own a personal 3D printer in the comfort of their own home in the near future. The three processes of printing, selective laser sintering, fused deposition modeling, and stereolithography, are in the infancy stage and cannot be totally relied on just yet.
The more that our technology advances, we become more capable of producing new and innovative products to help make the world a better place. As Eleanor Roosevelt once said, "The future is literally in our hands to mold as we like, but we cannot wait until tomorrow. Tomorrow is now."
Okay, so those are the three methods for additive manufacturing. And apart from that, we have material jetting is another method. It is an additive manufacturing process in which droplets of build materials are selectively deposited. Sometimes a single nozzle or a multiple nozzles. So with this multiple nozzles, you can also get a multiple color component. So the nozzle will move in all the three directions, and ultraviolet light will be applied to generate a heat source. So again, here also a layer by layer material will be exposed. So another method in additive manufacturing is binder jetting, where the process in which a liquid bonding agent is selectively deposited to join powder materials. Okay, so some of the minute parts or some hearing aids, such kind of small components using powder materials with a binding material, we can create a parts. And the material extrusion is another method. It is also used in some of the FDM technologies and additive manufacturing process in which material is selectively dispensed through a nozzle or orifice. For example, Stratasys FDM machines, they use this extrusion method. The wire will be fed, and that wire will be exposed to the heat source, and the wire will get liquefied and it will pour onto the profile. So powder bed fusion method is also again selectively it fuses the regions of the powder. So this method will be used in SLS, selective laser sintering, as well as polymers and metals and ceramics. You can use these materials, you can use in this SLS. Okay. And another method we just now we have seen stereolithography and selective laser sintering, where the each source is laser. And the polymers will get exposed to laser to form the required profile, selectively cured by the light activated polymerization. So stereolithography is one technique used by photopolymerization. Okay, so by looking at all these methods, essentially what is happening here is you need to model a component and convert that component into a slicing model that gives the SLS stereolithographic file. So basically it internally converts into a triangulates objects, and then once it is converted into a slices, again it will be like a G code and G codes of CNC mission. So the profiles, the locations, the whatever the slicing after converting the 3D model into slices, each slice is like a geometrical locations. The mission has to understand the profile using a geometrical locations, and those will be converted into G codes, and in turn the 3D printing x-axis, y-axis, z-axis, the movement happens as it is happens in the CNC mission, and then there is a synchronization built between the movement of 3 axes, and then pouring the nozzle material through nozzle or through sintering process or through light source process. So essentially it will be a G code again. As I mentioned earlier, some of the components might, for example, if you look at here the component, here there is when you go from bottom to certain few layers, there is a lot of gap between these two legs. Okay, so there, if you start pouring the material, there is when you start pouring this fourth layer, there is a high chances that before solidification of that the material will fall down. So in such cases, you might need a supporting structure to avoid sagging and deformation of the hot plastic. Support structures can be placed manually or generated by a software algorithm to stabilize large holes or gaps or overhangings during the print. These are some of the precautions at the time of 3D printing one has to take care. So they can be cut away once the component is printed. These supporting structures can be cut away. And then in case of multiple print materials, dissolved in water or acid. So some material which is left over or unwanted projections that can be cleaned using water acid in the process in the post process, so that you will get a required surface finish. Okay, so that's about the different methods and processes are used in the additive manufacturing. I hope I am not making you bore. After lunch, I know it's very difficult to focus. So some of the materials used in 3D printing are ABS material, thermoplastic, acrylic materials, metals like stainless steel, various silvers, glass materials you can use, ceramics, resins, sandstone, rubber, all these types of materials you can print. So if you look at the technology versus what materials you can print, as we have seen, the extrusion process, the FDM, fusion deposit modeling, comes under FDM process, or we can also call it as fused filament fabrication. So the thermoplastics, eutectic materials, edible materials, rubbers, modeling clay, metal clay. So these are the different kind of materials you can use in the FDM method. Whereas light polymerized technologies like stereolithography, so essentially use photopolymers in that methods. And powder based technologies are like EBM method, SLM method, selective laser melting, selective laser sintering, and direct metal laser sintering. All these technologies uses multiple materials like SLA, photopolymers again. EBM, almost any metal alloy, including titanium alloys, you can use there. And SLM, titanium alloys, cobalt, chromium, etc., stainless steel, aluminum, any material you can print. And selective heat sintering is another method where thermoplastic powders will be used. Selective laser sintering, as I mentioned earlier, thermoplastics, metal powders, ceramic powders can be used. Direct metal laser sintering is metal printing, actually. Almost any metal alloy you can use in this technology. Laminated, the LOM, laminated object manufacturing, where you can use paper, metal foils, plastic films. Basically what happens is multiple laminations. By using some binding material, these laminations will be joined to form the model. Wire technology, electron beam freeform fabrication is another technology. Almost any metal alloy you can use. So this will give some brief idea what kind of range of materials you can use in these technologies. Okay. So let's look at various applications. I know many of you might be always aware of, already are aware of the applications, but however, I would like to highlight some of the applications. So this technology has applications in medical, dental, extensively they are using, architectural area, domain, engineering, you name any field like automobile, aerospace engineering, any engineering field, you have applications of this technology. Chemistry, and you have applications in archaeology, sculptures, art, all these domains you have various applications. Let's look at how they are using this technology in these areas. Okay, so this picture comes under a sculpture. So this kind of sculptures can be built using the 3D printing. Okay, so yeah, so I don't want to elaborate this. So multiple more complex geometries can be achieved through this, because if you go for a conventional manufacturing, the internal features or structures, if you want to get, then you might need to go for a multiple axis CNC machines, or if a component is not able to get a required curve, then you might need to go, instead of 2-axis machine, 2.5 axis, you have to go sometimes 3 axis, sometimes like more turbine related or more complex related structures, you might need to go to 4 axis or 5 axis or 6 axis. So the amount of number of axis involved in the machining, the mission the cost of that machine will increase exponentially. So very rarely we use 6-axis machines for the components, unless in a aerospace domain or a defense related projects. We in the normal consumer shops, we will not go for a 6-axis or 5-axis machines. Hence, those are very expensive. So this technology is helping us. No need of those number of axes to produce the component. The internal features, as long as you are able to produce a design model, either using a straightforward engineering using curves and geometries, or a reverse engineering like capturing the point cloud data of the component and then building a model using a reverse engineering. Also, you can obtain a model, and that model, once you have a model, then you can do the slicing and printing. So that's what here it is telling. Any amount of complexity of geometry, any amount of internal features, any complexity can be achieved, and enables business models used for 3D printing, 2D printing, such as for photographs, to be applied to physical components. Okay, print your parts at home, at a local store, or order through Amazon like website like shapeways.com. So the business scenario is changing. Okay, so what essentially is you can order some of the components, or you can get some components from some sites like shapeways.com, or some other sites are there where you can get the pre-modeled components, and then those components you can use and then print it. Okay, so user changeable web content plus a network of additive manufacturing producers is already enabling new entrepreneurial opportunities. So all these companies like shapeways.com, freedom of creation, some fingerprints, these are some of the companies evolved after these concepts. So they essentially get the components from the net, and they will print it and sell it over the net. Okay, so like these technologies are giving an opportunity to new entrepreneurs. Okay. So impact on logistics. This technology has a lot of impact on logistics because you can design anywhere, manufacture anywhere is now possible. Means earlier in the conventional manufacturing method, you have to procure the raw material and then you will be manufacturing and then keeping as a work in progress or some inventory before giving to the customer. That maintaining the inventory itself is a very big task and lot of investment involved. And if it is expensive components, and keeping multiple components for a long time, economically very difficult for the organizations to maintain. So all those things have been arised from this technology. Here you can design whatever you want and print anywhere. You can design anywhere and simply transfer the design, and somebody will print you and deliver you. Or you can design at your own place and you can print at your place. Manufacture at the point of need rather than at lowest labor location. Okay, so that is the change in the logistics. That means you don't need to transport the raw material from one place to other. So that will reduce the transportation in a huge way, and changing just-in-time delivery to manufacture on location just in time. So you can just order the things, within no time you will be getting the component, or you yourself can print. So that way it has a lot of impact on the logistics. And it is hard now it is matured in some of the Western countries, but in India it is picking up a very, very higher pace. The funding agencies like UGC and DST are very much inclined towards giving lot of funding for R&D related to additive manufacturing or 3D printing. Newspapers, magazines, TV shows, everybody is talking about 3D printing and additive manufacturing. A lot of business acquisitions and mergers are happening in this area. Most major manufacturers are spinning up R&D. So they are looking at how to make their conventional, some percentage of components using 3D printing. Essentially, a lot of buzz around the market. Okay, let's just look at some of the players in this market. MakerBot is one of the promising mission. And as you know, Stratasys is one of the pioneer in this 3D printing area. They sell printers as well as printing materials. Okay, so you can build many types of toys, functional toys. And as I mentioned, there are a lot of applications in dental implants or human implants in an orthopedic area or dental area. And this is, I think, toys manufacturing, and in the architectural area also there is a lot of scope to apply. So if you look at some of these images, there is a printers to print the sculptures which you see on the roads majority of times in the Western countries. Such kind of sculptures you can see. So those can be built within no time using these printers. Otherwise, getting those features with a conventional manufacturing is very difficult. Okay, so you can print your face, and some of the slicing softwares like 3ds Max, Blender, Google SketchUp, some of these tools you can use and generate a STL file. Yeah, see some of the medical applications, dental implants, and not only dental, orthopedic implants also you can print, and then the doctors are doing a trial and error like research purpose. These implants are very much used in the medical field. Okay, so if you look at this beak, the complexity to generate this beak through conventional manufacturing process, definitely you need 4 to 5 axis to 6 axis machine to accomplish these kind of structures. But with additive manufacturing, without any small support materials and small setup, you can accomplish this. Whereas in conventional manufacturing, you need a lot of jigs and fixtures to hold these kind of complex shapes. Of course, you have a casting and other technologies, but getting a smooth surface finish is again, you need a lot of other processes to do that. Coming to general applications, like a lot of interesting stuff you can do with additive manufacturing. See what is happening here. After mother, you see after the scanning of 5th month or 6th month, you can get that scan image, and then you can convert that scanned image into a model using reverse engineering, and then subsequently you can make it a slice and then print and you can see your baby before birth. That is a kind of scope this has. Okay, and then literally one of the video explaining the 3D printing food is becoming normal. Chocolates, cookies, anything you can customize to your requirement or your taste, and you can print whenever you want. Such kind of not only the food, and you have home applications like toothpaste, toothbrush. You can customize your toothbrush according to your tooth profile, and so you can change the hardness of your toothbrush, those strips, color you can change, you can customize that, and you can print at your home. Okay, so as I'm mentioning, one of the cave in Tokyo, they are just printing their fiancé during the Valentine special. So they are making a lot of business on it. Like that, India also, these similar things are going to happen very soon, and maybe every household might have a 3D printer in the near future, not very far away. So let's look at what are the facts and forecasts this technology has. I will take 5 more minutes before touching upon the sustainability. So some time back, I just saw this information. By 2023, the 3D printing additive manufacturing market worldwide might be a 7.7 billion euros. By 2013, it is projected 2.2. Now, by 2018, it is 4.5. But by 2023, it is going to increase up to 7.7 billion. So it has by looking at this, there is a lot of scope in this area. Coming to Indian market, 3D printer market is expected to be $80 million business by 2021. So majority of these happening in automotive applications, biggest chunk of business, and educational and medical applications are also expected to witness good growth in this area. And other niche applications include art, crafts, interior decorations, fashion, accessories, footwear, jewelry design, animation and gaming, customized footwear designs, furniture and modeling. Every area it has a tremendous scope. Already we are seeing majority of house furnitures coming with a single piece. So those are printed by the 3D printers. Major players active in India 3D printing market, including manufacturers and distributors, Altem Technologies, and 3D Brahma 3. Some of these companies they are actively engaged in this area. Okay, so if we go into some kind of statistics, you can decrease the cost of a product at least by 50% in terms of euros. It has been mentioned here, but so 400% faster by 2023. But at this point of time, by 2021, I cannot claim this 400% faster, but the research is happening. A lot of effort is going to improve the speed of the printing in terms of improved design of nozzles, improved designs in the technologies which we are using. So whoever wants to do research in additive technologies. One of the promising area is looking at the current methods and their limitations. And then from the limitations, we can get some clues to improve those by having optimized parameters like improving the fastness of print, etc. So that is one of the promising area one can look at, and the funding agencies are very much willing to give funding to such projects. So rapid prototyping, very much used in this technology as some of the tools. If you want to manufacture, you need a die, and so those dies, creating one or two using 3D printer is very affordable. For creating one or two tools, one or two components, a conventional manufacturing setup become very expensive. So hence, the rapid prototyping area, lot of applications are there, 3D printing applications. And spare parts, using additive manufacturing reduces repair times and avoids costly warehousing. Siemens is already using the technique to repair the burner tips of small gas turbines. So by using this technology, they are already reducing 40% of labor cost and 90% faster the repairs they are performing. Okay, so you have a scope in this technology. You can customize your items while printing. You can also do small batches. It is very costly to create molds and production lines for small batches. Such items can be produced cost efficiently with additive manufacturing. Very complex pieces, very complex geometries, it's very easily created using additive manufacturing. Used to produce very complex work pieces, which would be almost impossible to create with previously available techniques. One possible area of applications is that of gas turbine blades, in which ventilation ducts could be integrated for cooling. Okay, some of these complex components can be accomplished. So if you look at some facts, dentistry and dental technology already capable of full-scale production, and mission tools and manufacturers might be 9 to in a scale of 1 to 10. They are extensively using up to 8.5 to 9. They are printing actual functional components and using in the real-time assemblies. And aerospace is extensively using initial systems already manufactured, and they are applied. And some more areas are looking at this technology very seriously to incorporate. Okay, so to look at the pricing and the top-rated 3D printers by print quality, this is a brief list. Some of the printers which are there in the left side, 3D printer models, and their print quality, millimeters per second, speed, and then quality in terms of microns, 300 microns, 100 microns, 20 microns, 10 microns, and their price range. It is slightly old rates, but some of these rates might have decreased. Okay, so that gives a brief idea how much print quality you can get. You can get up to 300 microns, up to 30 microns, 20 microns. That is the surface finish you can get. Okay, so having said that, so as we discussed, we can reduce the wastage of material and logistics. There is impact on the logistics, right? So with this, the sustainability as a definition as such, sustainability is integration of economy, society, and environment. Okay. If you look at these three, how we are impacting with this technology. So let's look at material sustainability. Almost no wasted materials. That means it is economical, and whatever the material we are wasting through conventional method, we can save. No need for a massive product inventory. That also is economical, and encourages good design, product optimization, zero cutting tools. So, and zero cutting tools is another advantage to the environment as well as to economy. The cost of cutting tool is zero, and then when you say cutting tool, after cutting tool, then you have to dispose the after worn out, right? So the disposal will create a problem in environment. That is also not there. And cutting emissions down, because we are reducing the transportation. As I mentioned to you, there is a logistic impact. You no need to inventory, you need to maintain the inventory. You no need to transport the components from where it is manufactured to the customer. So you can design, you can manufacture anytime, and you no need to maintain the inventory. All these comes to economically and environmentally friendly. And utility clean energy. You can some of these techniques, you can use a clean energy like solar power also you can use to run the 3D printers like that. So when you reduce the transportation and cutting emissions, that indirectly impact to the environment and society. So that way, this technology is sustainable. So to conclude, given the huge opportunity that exists in the market and the rapid consolidation that is taking place, it is certain that 3D printing will be adopted a lot more across industries. Added to this is the fact that startups and entrepreneurs in India are seeing immense potential and benefits in 3D printing technology. It is only a matter of time before a compact and low-cost 3D printer comes out of India that will become a must-buy during Deepavali or any festival for Indian households in near future. Before I just want to play this and then we'll conclude.
Traditionally, when you think of printing, you think of printing out something on a piece of paper using ink. Well, 3D printing is actually printing out a physical object. You have a digital image that you can create using different animation modeling softwares. You connect this image with your 3D printer, and it actually takes that, analyzes it, and it prints it out in physical form, layer by layer. If you think about traditional printing, you have syringes with ink. With 3D printing, you can have syringes filled with all different types of liquid consistencies. So this could be plastic, this could be rubber. Some more advanced ones are using metals. Manufacturers have been using 3D printing for decades, and you can print out car parts. Aerospace industry uses this, but also more and more you can print out really creative things. Doctors are printing out prosthetic limbs. You can
excuse me, sir.
We spoke to
Hello.
a fashion designer who was able to actually 3D
no video,
print
sir. No video.
No video happening.
for fashion
Sir, only audio is coming. No
Okay.
video is coming.
Okay. I'll stop
Please
it
play.
here.
Yeah.
Seems to be.
You can play it once again, sir. You can play it once again.
Play it once again.
Yeah, you can check it because only audio is coming, no video actually.
Now?
really expensive. We're
No,
talking
sir,
like
no.
$500,000. But now,
Okay, 1 minute.
a couple different companies came and they said, you know what, we want to make this so average people could have this. You can probably get one for about $1,000. So let's say I had a jacket and I lost my button. Instead of going and trying to go to a store and find a new button, I could actually download the blueprint, connect it with my 3D printer, and I could print out and think about printing of
So no video, sir.
Okay, sorry.
Okay.
I'll come out of sharing, okay? Stop. Sorry. Can you just stop sharing?
So we haven't shared anything, sir. You can share the screen now. So you can share the screen now. We didn't share anything. You can share the screen straight away.
their website off for 5 years. Joel, going to help me.
Sorry for that.
It's okay, sir. You can make this full screen
Yeah,
now.
I'll do that. Yeah. So I almost 2 hours completed my talk.
Okay, sir.
So with that, I want to conclude. Thank you for active listening. Any questions?
Sir, one of the participant is having question. I will allow them to speak to you. You can speak to them, sir.
Yeah, please.
Hello, Ramni madam. Hello. Ketaki Ramani madam. Hello. Sir Krishna ji, sir, you can speak now.
Hello, sir. I have a question, like how these materials are chosen while making these 3D structures or images?
Can you come again? What do you mean by how do you choose
what material has to be chosen? Like how these machines will support the particular type of the material that is to be used?
Okay, so as you see one of my slide, I have clearly listed out the technologies and what are the materials which these technologies support, right? Can I share that slide again?
Please.
1 minute. Yeah, are you able to see?
Yes, sir.
Oh, sorry, what happened? Now?
Yeah, sir. Materials.
Yeah, so for example, if you take extrusion processes like FDM, the materials which is listed in the materials column, those are the materials it will support.
Okay.
Okay. So if you take a powder bed related technologies, so all these type of powders, polymer, photopolymer kind of metal, titanium alloys, thermoplastic powders, all these materials it will support. Suppose you want to print like any titanic alloys using FDM, it's not possible because the metal printing is not that happened using the FDM. Okay, so when you are trying to select a certain technology based on your material available or what kind of material you want to print, so based on those materials and appropriate technology you need to choose.
Okay, sir. Thank you, sir.
Okay. Any other questions?
So in the Q&A box, there were a few questions. You can answer those questions, sir.
Oh, okay. 1 minute.
Beside chat box.
Chat box.
Beside chat, you have Q&A box now, sir. There were a few questions.
Right. I had to stop sharing and then
Yes, sir.
go to chat.
Yes, sir.
Oh, there are 10 charts listed here.
So not chat, sir. Q&A, question and answers.
Q&A. Oh, okay.
Q&A.
I think there are four people responded.
Yes, sir. Yes, sir. You can answer those questions.
First one, can you consider additive manufacturing as a sort of lithographic process of synthesis of nanostructures? Okay. No idea, because I'm not too into nano materials and nanostructures. Maybe since the size is very small, nano structures and nano thing, I don't know, but up to 5 to 10 microns, you can print the quality up to 10 to 20 microns. But nano, what is the size? 10 to the power of minus 9, right? No, I need to check on that, because I don't know such a small sizes it will handle or not. So next question. Is that answers? Kaushik. Next question, Sri. Sir, I am not able to unmute. My question is, which type of material best suit for additive manufacturing? So the list which I displayed against each technology and materials, any of those materials, and but you need to have an appropriate technology to print. Okay. Is there any specific property should be there for material? Yes. So there is a solidification, and as soon as the heat source is applied into the raw material, so the solidification temperature should be within that range. Then only you can use that material. If you are not able to make it into liquid at that temperature, ultimately the nozzle has to pour, and or either laser heat source has to be applied onto the powder. That powder has to convert like into a liquid, and then subsequently it has to go for a solidification. Then only the required structure will be obtained. Yes, definitely that property should be within that range. And coming to, can these materials be reused and recycled? Otherwise, disposal would be difficult. Yes, certain extent, definitely it will be reused. The powder which is not melted, that means once it is melted, and it will be the recrystallization of that material powder will be changing. So that cannot be reused, but maybe more than required powder might be required, because the layer by layer we are making the powder bed down, but 100% of that material we are not exposing to the heat source. So whatever the material powder which is not exposed to heat source can be reused. So those are the 4 questions.
Yes, sir. I think there are no more questions on this topic. Right, sir. Thank you, sir. Thank you very much. That was an excellent presentation, and it is a valuable information for active researchers and faculty members for doing research in this field. The presentation highlights about sustainability in manufacturing related to economy, society, and environment, and that was a nice illustrative display. Thank you, sir. Thank you very much for accepting our invitation. And I thank on behalf of Mechanical Engineering Department, GITAM School of Technology, Bangalore campus. Thank you, sir, for your valuable time and for being with us. Thank you very much, sir. I thank all the participants.
Thank you all participants. Wish you good luck. Thank you.
Thank you, sir. I thank all the participants for their active participation, and I request all of you, all the participants to join for the last day of the Digital FTP tomorrow at 9:30 a.m. Thank you, sir. Thank you very much, sir.
Thank you. So
Thank you,
you can reach me anytime. My email ID is there in GITAM website. I am a HOD Mechanical Engineering, Hyderabad campus. Thank you all.
Thank you, sir. Thank you.
Thank you all, sir. Thank you.
Thank you, sir.
Thank you, Raghuvamshi, sir.
Thank you, sir.
Thank you, the panelists, Sandeep, sir, Professor Santosh. And I thank all participants.
Thank you, sir. Thank you.